First of all, I welcome all the students and the participants who are attending this live lecture. See this, in this today's live lecture, we shall discuss the next concept, the ordinary differential equation. Ordinary differential equation. In that ordinary differential equation, we shall discuss the particular type, that is exact differential equations. What is meant by exact differential equation? Which type of a differential equation is called as exact differential equation? Today we shall discuss this lecture in this lecture, okay? Now actually in our syllabus this is chapter number 4, and in that chapter number 4 we have to discuss the exact differential equation. Okay. Now see this, what is meant by exact differential equation? Before starting, actually exact differential equation is the differential equation whose degree is first, whose order is first. First order, first degree differential equation is exact differential equation, but it must satisfy some condition. Actually in the previous lecture we have seen the different 8 solution methods for the first order first degree differential equation. Now this is the 9th type. Exact differential equation is another 9th type method which is specially used to solve the differential equation which are in first order first degree differential equation. See this, आज्ञा वडवळे, संभाजी, प्रीती क्षीरसागर, योगेश घोडके, पूजा अंदुरे, सारिका परळे, माधुरी, नेहा बोळेगावे, नाज, मोहिनी काळे, नंदिनी, ऋतुजा. Okay, so this is the general differential equation. This is the differential equation which is in the separation variable form which we have studied. Only I am going to revise this. This is the differential equation which is a particular type, and such differential equation can be solved by putting ax plus by plus c. Again the differential equation dy by dx which is equals to f of y by x. It may be homogeneous, it may be non-homogeneous, but function is as like y by x, then we can solve such a differential equation by putting y by x is equals to u. This is the homogeneous differential equation form, then we have to put y is equals to ux. This type of a differential equation is called as a linear differential equation. We can solve this differential equation by using this method. Now general first order differential equation is y dash of f of x comma y. So this is the also variable separation form, then its solution can be written in this way. Also in the last lecture we have seen the first order first differential equation of the type y dash is equals to a1x plus b1y plus c1 divided by a2x plus b2y plus c2, where a1, b1, c1, a2, b2, c2 are constant. Then such types of differential equation also solved by converting homogeneous differential equation. First of all we have to convert this given differential equation in the form of a homogeneous differential equation. This is actually non-homogeneous differential equation in first order first degree. So first of all we have to convert this in the form of homogeneous differential equation by using particular substitution. X is equals to x capital X plus h, y is equals to capital Y plus k. Then convert this and find the values of h and k such that both the brackets will be 0. Then we will get the homogeneous differential equation form, and again solve by using the homogeneous method. Okay. Now we shall discuss the differential equation. See this, the differential equation of the for capital M of x comma y plus n of x comma y into y dash which is equals to 0, or this can be written as, यालाच आपण असं शुद्ध असं खाली लिहिलेलंच आहे, capital M of x comma y plus capital N of x comma y which is into y dash which is equals to 0 is said to be exact when there exists a function f such that dou f divided by dou x which is equals to m, dou f divided by dou y which is equals to n. If this condition satisfies, then we can say that the given differential equation is exact differential equation. Or there is another definition, another form of the differential equation. If m and n are the functions of x and y, then the equation capital M into dx plus capital N into dy which is equals to 0 is said to be exact when there exists a function f of x comma y such that dou f divided by dou x which is equals to m into dx plus dou f divided by dou y into dy which is equals to m into dx plus n into dy. That means m is equals to dou f by dou x plus n is equals to dou f by dou y. If this condition satisfies, then we can say that the given differential equation is exact differential equation. Now, for example, suppose we shall discuss one example regarding the homogeneous exact differential equation. The differential equation, suppose we consider the differential equation y square dx plus 2xy dy which is equals to 0, or we can write y square plus 2xy into dy by dx which is equals to 0 is an exact differential equation because there exists a function f of x comma y which is equals to x into y square such that for that function we can write dou f by dou x which is equals to y square and dou f by dou y which is equals to 2xy, means dou f by dou y is equals to m square, m dou f by dou y which is equals to n. So this equation is called as a, so we can say that the given differential equation x square into dx plus 2xy into dy which is equals to 0 is called an exact differential equation. See this? Now we can write, suppose f of x comma x into y square. If we take the derivative, of x into y square according to the partial derivative, then you know that derivative of first, second as it is, means y square, see this, second as it is, derivative of first plus first as it is, see this, first as it is, derivative of second y square is a derivative 2y dy. So we get x into y square means x square into dx plus 2xy into dy. Therefore, x square into dx plus 2xy into dy is called as a exact differential equation. And so we can write x square dx plus 2xy dy is equals to 0, replace this 0. Sorry. Therefore, derivative of x into y square is equals to 0. अगर किसी भी फंक्शन का डेरिवेटिव 0 होता है तो वो फंक्शन कांस्टेंट होना चाहिए. इसका मतलब x into y square must be constant, and which is the solution of the differential equation. That means f of x comma y which is equals to c, and which is the solution of this differential equation. See, this is one procedure which we have expressed here according to the definition. हमने यहाँ पे क्या किया है, एक एग्जाम्पल एग्जैक्ट डिफरेंशियल इक्वेशन का एग्जाम्पल दे दिया है. उसमें हमने फंक्शन कंसिडर किया है एफ ऑफ एक्स कॉमा वाई विच इज इक्वल्स टू एक्स इंटू वाई स्क्वायर. इसमें ये कंडीशन सेटिस्फाई होती है डो एफ डिवाइड बाई डो एक्स इज इक्वल्स टू वाई स्क्वायर एंड डो एफ डिवाइड बाई डो वाई इज इक्वल्स टू 2xy. इन दिस केस अगर हम डेरिवेटिव लेते हैं तो derivative of x into y square, then we get the result. Okay, this is a very simple concept. There is no any typical concept here, but you must know the differential equation. The format of a differential equation: m into m of x comma y plus n of x comma y into y dash is equals to 0. This type of a differential equation is called as exact, but it is essential that it must satisfy the condition dou f divided by dou x is equals to m, dou f divided by dou y which is equals to n. अगर ये कंडीशन सेटिस्फाई होती है तो हम इसको एग्जैक्ट डिफरेंशियल इक्वेशन बोलते हैं. ओके, नाउ नोट, an exact differential equation can be derived from its general solution directly by differentiating without any subsequent multiplication or eliminating. That means, see this, we can find the solution of an exact differential equation by deriving the function directly. If we derive the function f of x comma y directly, then we get the solution. Definitely we will get the solution. Okay, so this is the note. Now second, suppose that, now we shall discuss the theorem number first. Actually here we have to discuss one important theorem, and that theorem number first, that is actually in this chapter this is a theorem number second, so we can write theorem number second, there is no problem. Now suppose that the equation, this is the statement of the theorem, m of x comma y plus n of x comma y into y dash which is equals to 0. रचना बहुत लेट ज्वाइन हो रहे हैं. रचना भागवत, गणेश काळे, M.Sc.F.Y लिहिता वेळेवर जॉइन व्हायचं रे. Suppose that the equation m of x comma y plus n of x comma y into y dash which is equals to 0 is exact in a rectangle R, and f is a real valued function such that dou f by dou x which is equals to m, dou f by dou y which is equals to n in R. Then prove that every differential equation, every differential function phi which is defined multiplicity by the relation f of x comma y which is equals to c, or f of x comma phi of x which is equals to c, is a solution of the differential equation and whose graph lies in R. It is not problem whose graph is in R. Now we shall discuss the proof. See here, we know that the first order general differential equation is of the form we have studied. The starting of this chapter is from this differential equation, general differential equation. We know that the first order general differential equation is of the form y dash is equals to f of x comma y. If the differential equation or f of x comma y is particularly in this way, f of x comma y can be expressed in the way minus m of x comma y divided by n of x comma y. That is y dash is equals to minus m of x comma y divided by n of x comma y, or we can write m of x comma y plus n of x comma y into y dash is equals to 0, or this can be written as m dx. Y dash means we can write dy by dx. If we replace this y dash in the form of dy by dx and by multiplying dx, then we get this equation. This is also exact differential equation in the general form or in the form of dy by dx. Okay, so different types of books uses different notations, different concept, different solution methodology, but we are using here the book, particular type of book, that is a Codington. So we have to use the methodology regarding the Codington. Okay. Now see this capital M of x comma y into dx plus n of x comma y into dy, which is equals to 0, where m and n are real valued functions of x comma y on some rectangle R. Rectangle means in this way, it has some condition. Some condition, it having this condition for x and y. Suppose A lies between A to B, small x lies between A to B, and small y lies between, suppose, C to D. So this rectangle, this belongs to R. Okay. So this is a rectangle, no problem. The differential equation 1 is said to be exact in R if there exists a function. Suppose this is x-axis, this is y-axis, you can complete this procedure. Or if there exists a function according to the definition of the exact differential equation, when we can say that the given differential equation is exact, if there exists a function f such that dou f by dou x which is equals to m, dou f by dou y which is equals to n, which is in R. Here f is a function which satisfies the condition 2. अगर condition 2 satisfy होता है, f satisfies the condition 2, so we can replace this m by dou f by dou x in equation 1. So put this value of, see this, put this value of m, we can put the value of m of x comma y by f, so we get dou f by dou x of x comma y plus dou f by dou y. Here put student, here you have to put dou f by dou y of x comma y into y dash, because see this n is considered as a dou f by dou y according to the definition of the exact, into y dash is equals to 0. If suppose phi is the solution of, suppose that phi is the solution on interval I. आता या इंटरवल मध्ये जर phi solution असेल, suppose there is a solution phi, okay, in the given interval, then we can write that is y. Replace this dou phi by dou x which is equals to x comma phi of x plus dou phi by dou y which is equals to phi dash of x. समजा हा x इथं आहे. 1 minute we shall explain this concept. Suppose this is x, then there exists a solution which gives a phi of x. Phi of x is the solution of the differential equation. So on interval I, then see this, we can write y, we can replace this y by phi of x. This is the simple concept. Into y dash means phi dash of x is equals to 0. Suppose this is equation number 3 for all x in I. x हा कुठं असेल, interval I वर असेल. Suppose this is the interval I, x is in interval I. If suppose phi of x is equals to f of x comma phi of x, then the equation 3 can be written as, if phi of x is equals to f of x comma phi of x, then equation 3 can be written as, because if we differentiate this, याचं differentiation घ्या, दोन्ही साइडचं differentiation घ्या. How we can take, if we take the differentiation, then phi dash of x is equals to, how we can write, dou f by dou x into dx, we consider f of x comma y, plus dou f by dou y, or we can write in this way also, dou f by dou x plus dou f by dou y. Y means actually phi into phi dash of x, which is equals to 0. F is a function of x comma y, but this value of this function is equals to 0. So we can write phi dash of x is equals to 0. So we can put here the phi dash of x is equals to 0. That means we can write आता phi of x is here, phi of x is equals to this, phi dash of x is equals to 0, means f dash, suppose this is f dash of x comma phi of x is 0, that means f of x is equals to constant. अगर किसी भी फंक्शन का डेरिवेटिव अगर 0 होता है, सी दिस, डेरिवेटिव अगर 0 होता है तो वो फंक्शन कांस्टेंट होता है, वो फंक्शन क्या होता है, कांस्टेंट होता है. So we can also write phi of x is equals to constant. So that means f of x comma phi of x is equals to constant. Thus the solution phi must be a function which is given multiplicity by the relation f of x comma y, which is equals to c for all x in I, and derivative satisfies the equation 3. Hence phi of x is the solution of differential equation 1. Hence the phi of x is solution of differential equation 1, and hence proved. अशा पद्धतीने हा थेरम प्रूव्ह होतो. खूप सिंपल थेरम आहे, काही अडचण नाही आहे या थेरम मध्ये. Actually it is the very simple theorem, so you can use this. Now actually how to solve the problems based on this is very important. So working rule, we can solve problem by using these steps of the theorem. Theorem च्या स्टेप प्रमाणे आपण सॉल्व करा. You can solve the problems based on this theorem, or you can solve problem by shortcut method. Exact differential equation, the solution of exact differential equation can be made easily by using this shortcut method. See this, integrate, first of all you have to rule, see this working rule for the solution of the differential equation, and that may be exact differential equation. First of all, what we have to do, integrate m with respect to x keeping y constant. First of all, you have to integrate that function with respect to x, m with respect to x. Integrate, then see this, integrate n with respect to y, only those terms not contain x, only those terms not contains x. Or number third, take sum of two integrals, then integration, first an integration taken with equating an arbitrary constant. So we get the solution. This is the first method. Now you can use this second method directly. The solution of m of x comma y dx plus n of x comma y dy, which is equals to 0. This is the exact differential equation. Then directly the solution can be written as capital M dx, integration of capital M dx, but keep y constant, plus integral of capital N dy. We have to take the integration of n with respect to y, but we have to select the terms in n which are not containing x, which are not containing x. According to this, if we take the integrating and then addition, which is equals to the constant term according to the theorem, because we know that f of x comma y, which is equals to c, it is the solution. Okay. So first of all, I shall solve one problem which is based on the theorem. मैं काय करें, यहाँ पे मैं पहले क्या करता हूँ, एक थ्योरम, एक प्रॉब्लम इस थ्योरम के आधार पे सॉल्व करता हूँ, और बाकी के जो भी प्रॉब्लम्स है वी कैन यूज दिस मेथड. ओके, सो नाउ सी दिस फर्स्ट example. problems. So we can find all the solutions of differential equation following differential equation. असं करू, differential equations given below. इसमें से first we can take one example, that is y dash which is equals to 3x square. Suppose we consider y dash is equals to 3x square minus 2xy divided by x square minus 2y. So, okay, this is the symbolic form of a exact differential equation, but we have to write this differential equation in the form of m dx plus n dy. So, this given differential equation is हे विद्यार्थ्यांनो, तुम्हाला मी स्ट्रिक्टली सूचना आहे, आता फास्ट सर्वांनी आन्सर देत राहायचं. लिहून घेत असताना प्रॉपरली अत्यंत चांगल्या पद्धतीने स्टेप बाय स्टेप लिहून घ्यायचं. मॅथमॅटिक्समध्ये पर्टिक्युलर स्टेप बाय स्टेप रायटिंगला खूप महत्त्व आहे. त्यामुळे तुमची नोटबुक वगैरे स्टेप बाय स्टेप असली पाहिजे. डायरेक्ट स्टेप नको आहेत. जरी समजलं तरी डायरेक्ट स्टेप नको आहेत, कारण वाचणारा रीडिंग करणारा कुणी जरी असेल आणि तुमची जर नोटबुक रीड करत असेल तर त्याला सर्वच्या सर्व नोटबुक अत्यंत परफेक्ट समजली पाहिजे. सो वी कॅन राईट y डॅश इक्वल्स टू 3x square minus 2xy divided by x square minus 2y. So this can be written in the form of particular form मध्ये लिहू, dy by dx equals to 3x square minus 2xy divided by x square minus 2y. आता क्रॉस मल्टिप्लिकेशन घ्या, सबट्रॅक्शन करा. मग क्रॉस मल्टिप्लिकेशन घेऊन सबट्रॅक्शन केल्यानंतर कसं येतं पहा, वी कॅन मल्टिप्लाय बाय दिस. सो x square minus 2y into dy which is equals to 3x square minus 2xy into dx. Now you can take this term on left side. You can take this term on left side. So it will be minus. Therefore, we can write 3x square minus 2xy into dx minus x square minus 2y into dy which is equals to 0. But you know that the standard form of a exact differential equation is, what is the standard form of exact differential equation? M dx plus n dy. That means we need here a plus. So we can write this as 3x square minus 2xy into dx plus 2y minus x square. You can take minus common from this bracket, then we will get minus minus plus into dy which is equals to 0. Suppose this is the equation. Comparing, now we have to compare. Comparing with, आता एक्झॅक्ट आहे अगोदरच नाही सांगता येणार, म्हणून कंपेअरिंग विथ एक्झॅक्ट डिफरन्शियल इक्वेशन म्हणायचं नाही. वी कांट से डायरेक्टली हियर एक्झॅक्ट डिफरन्शियल इक्वेशन. वी हॅव टू व्हेरीफाय द कंडिशन. सो कंपेअरिंग दिस विथ m dx plus n dy which is equals to 0. Okay, so now you tell me, student, what is the value of m? M means 3x square minus 2xy. That means n is equals to 2y minus x square. Now we have to first of all verify the condition. अभी क्या करना है आपको? कंडीशन वेरीफाई करना है. Now we have to discuss. अभी वेरीफाई करना है कंडीशन. तो कंडीशन वेरीफाई करना है तो कौन सी कंडीशन है, डो एम बाय डो एक्स। मैंने आपको यहाँ पे लिखा नहीं है गिवन कंडीशन, फंक्शन तो नहीं है, मैं यहाँ पे नोट पे लिखता हूँ सबसे पहले। वेयर इज द नोट, ओके, दिस इज द फर्स्ट नोट। दुसरी एक नोट आहे ते आपण थेरम मध्ये घ्यायचे, ते आपण उद्या लावू. सो वी कॅन टेक दिस, द एक महत्वाची कंडिशन आहे, द नेसेसरी अँड सफिशियंट कंडिशन. आय शॅल राईट हिअर द नेसेसरी and sufficient condition necessary and sufficient condition for the exact necessary and sufficient condition for the differential equation m dx plus n dy which is equals to 0 to be exact, dou m divided by dou y which is equals to dou n divided by dou y, sorry, dou m divided by dou y into dou n divided by dou x. ही एक कंडिशन आहे, हा एक सेपरेट थेरम आहे. वी शॅल डिस्कस दिस थेरम ऑन टुमारो. हा थेरम वेगळा आहे, पण कंडिशन लक्षात ठेवा. जर एखादं डिफरन्शियल इक्वेशन कॅपिटल एम डी एक्स प्लस एन डी वाय विच इज इक्वल्स टू 0, हा जर तुम्हाला एक्झॅक्ट म्हणायचा असेल देन इट इज द कंडिशन डो एम डिवाइड बाय डो वाय which must be equals to dou n divided by dou y, sorry, dou n divided by dou x. इथं रॉंग झालं. अगर if this condition satisfies then we can say that this differential equation. आता अगोदर जो पाहिलेला आहे दुसरी कंडिशन ते फंक्शन y, if there exists a function f, if there exists a function f such that dou f by dou x which is equals to m and dou f divided by dou y which is equals to n, if this condition satisfies, ती कंडिशन वेगळी आहे. तिसरी कंडिशन कोणती आहे पहा, there exists a function, there exists a function, जर फंक्शन माहित असेल तर there exists a function f such that dou f divided by dou x which is equals to m, dou f divided by dou y which is equals to n, then m dx plus n dy which is equals to 0 is exact. हा थेरम आता पाहिलेला आहे, पण आपल्याकडे फंक्शन माहित असेल तर बट इन दिस प्रॉब्लेम देर इज नो एनी फंक्शन. या ठिकाणी तो फंक्शन नाही आहे, एफ माहित नाही. इथं वी हॅव टू कॅल्क्युलेट एफ कॅल्क्युलेट करायचं आहे. एफ माहित नसल्यामुळे आपल्याला इथं कंडिशन ऑफ एक्झॅक्ट डिफरन्शियल इक्वेशन वापरायचं आहे, म्हणजेच डो एम डिवाइड बाय डो वाय विच इज इक्वल्स टू, now take the differentiation of m with respect to y, take differentiation of m with respect to y. काय येतो रे सांगा बरं, याचा with respect to y न घ्यायचा तर इथं येतो याचा डेरिव्हेटिव्ह घेतला तर हा येतो कॉन्स्टंट. बघा y न घेत असताना कॉन्स्टंट मायनस 2x which is equals to, we can write this as a 2x. बरोबर आहे का, मायनस 2x and dou n by dou y, dou n by dou x which is equals to, आता n चा डेरिव्हेटिव्ह विथ रिस्पेक्ट टू x घ्या, 0 मायनस x स्क्वेअर चा डेरिव्हेटिव्ह 2x which is equals to minus 2x. So we can say that therefore therefore we can write, देखो both partial derivatives are same, therefore dou m divided by dou y, which is equals to dou n divided by dou y, therefore the given differential equation 1 is exact. So if this condition satisfies, पहा दोन कंडिशन आहेत एक्झॅक्ट डिफरन्शियल इक्वेशनच्या. अकॉर्डिंग टू द डेफिनेशन म्हटलं देर एक्झिस्ट अ फंक्शन, फंक्शन माहित असेल, कॅपिटल एफ माहित असेल. इफ यू नो द फंक्शन कॅपिटल एक्स, कॅपिटल एफ, such that dou f divided by dou x which is equals to m, dou f divided by dou y which is equals to n, then we can say that m dx plus n dy which is equals to 0 is exact differential equation. And the second necessary and sufficient condition is जर m dx plus n dy which is equals to 0 याला जर तुम्हाला एक्झॅक्ट म्हणायचं असेल, if you want to say m dx plus n dy which is equals to exact, then according to this differential equation dou m divided by dou y must be equals to dou n divided by dou y, then we can say that. मग या इक्वेशन वरनच f माहित असायची गरज नाही, f माहित असायची गरज नाही, डायरेक्ट या इक्वेशन वरनं आपल्याला हे म्हणू शकतो. ठीक आहे, तर वी शॅल राईट दिस. ओके, नाव हाऊ टू कॅल्क्युलेट दिस. आता ह्याचं सोल्युशन कसं कॅल्क्युलेट करायचं पहा. डो एफ बाय डो एक्स. नाव सी दिस. we know that according to the definition there exists a function, we have to calculate that function, capital X comma y, capital X comma y, capital X comma y, for all x comma y there exists a function capital X comma my such that dou f divided by dou x which is equals to capital M and dou f divided by dou y which is equals to capital N. Now put this value, dou f divided by dou x which is equals to capital M means you have to put 3x square minus 2xy. Okay, and dou f divided by dou y and dou f divided by dou y which is equals to capital N. Capital N means 2y minus x square. Now we have to calculate f. So by integrating now dou f divided by dou x which is equals to 3x square minus 2xy, integrating with respect to x. So कसं येईल पहा आता, इंटिग्रेटिंग विथ रिस्पेक्ट टू एक्स जर घेतला तर याचं इंटिग्रेशन डेरिव्हेटिव्ह कॅन्सल होतो. देअरफॉर कॅपिटल एफ इज इक्वल्स टू, मला सांगा बरं 3x स्क्वेअर मायनस 2xy चं इंटिग्रेटिंग काय येतं पहा. ह्याचा इंटिग्रेशन घ्या, इंटिग्रेशन घेतल्यानंतर काय येईल, दिस इज द 3x स्क्वेअर चं इंटिग्रेशन 3x क्यूब बाय 3 मायनस, आता परत इंटिग्रेटिंग विथ रिस्पेक्ट टू एक्स घ्यायला लागलो, मायनस 2x चं इंटिग्रेशन x स्क्वेअर बाय 2 इंटू y एज इट इज, plus we have to consider the integrating constant small f of y. This is the integrating constant. By integrating, suppose this is by integrating with respect to x, मी थेरम नुसार जातो. So f is equals to which of the following term, that is x cube, x cube, then x square y minus x square y plus small f of y. So this is our required function. This is our required function. We consider this equation as suppose m dx. Suppose this is equation number 2. We can take equation number 3. This is our required function f of x comma y. But note that here small f of y is a constant of integral. We have to calculate. At a small f of y, constant of integral, we have to calculate. So how we can calculate this? आता परत हे कसं calculate करायचं पहा. So we have to calculate this. आता where f is the independent of x, where f is independent of x, which is the constant of integration. Now we know that dou n by dou x, which is equals to capital N. Capital N means also we have written 2y minus x square. 2y minus x square. आता dou n by dou x. Dou n by dou x. This. आता हे आपल्याकडे पहा dou n by dou x means परत इथं dou n by dou x, सॉरी इथं एक मिनिट. dou n by dou x नाही, second equation पहा dou f by dou y which is equals to n. Now dou f by dou y which is equals to n. Dou f by dou y, n is given. What is that n? Actually n means 2y minus x square, which is dou f by dou y. आता f आपल्याकडे माहित आहे y plus f of y which is equals to 3. So we can write f is independent of x, so dou f by dou y which is equals to n, dou f by dou y which is equals to n means 2y minus x square. But we can calculate dou f by dou y from 3. आता इथं फ्रॉम 3 काढू शकता. काय dou f by dou y means इक्वेशन 3 चं इक्वेशन घ्या. काय येईल पहा 0 minus x square into 1 plus f dash of y which is equals to this as it is 2x minus x square. This is a from 3. So minus x square plus f dash of y, small f dash of y which is equals to 2x minus x square. So small f dash of y is equals to 2x minus x square plus x square. इथं परत तेच व्हायला लागले 2y. 1 minute 2y. इथं 2y होतं 2x बाय मिस्टेक होतं. So x square cancel. So f dash of y is equals to 2y. व्हेरी गुड. स्वप्नील सर्वदे सांगत चला रे, रायटिंग मध्ये लिहित चुका होतात. सो देअरफॉर f of y which is equals to याचं इंटिग्रेशन घेतल्यानंतर येतं y square divided by 2. 2 will be get cancel. Put in 3. याचं इंटिग्रेशन घ्या. देअरफॉर capital F of x comma y which is equals to आता 3 इक्वेशन x cube minus x square y plus f of y, that means x cube minus x square y plus f of y means how we can write, that is 2y, that is y square. This is the required solution of differential equation 1. दिस इज द रिक्वायर्ड सोल्युशन ऑफ डिफरन्शियल इक्वेशन 1. चला आता आपण दुसरे डिफरन्शियल इक्वेशन सॉल्व करू. वी कॅन सॉल्व सच अ डिफरन्शियल इक्वेशन बाय युजिंग दिस मेथड ऑल्सो. या मेथडनं सुद्धा सॉल्व करता येतं, तसे पण सॉल्व करू. See the second differential equation. Second, we can write the differential equation. Second, solve x square minus 4xy. Solve x square minus 4xy minus 2y square into dx plus y square minus 4xy minus 2x square into dy which is equals to 0. हाँ चला रे students, given differential equation is x square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square into dy which is equals to 0. Here you can compare m dx plus n dy. M is equals to x square minus 4xy minus 2y square. N means y square minus 4xy minus 2x square. Now if you want to show this differential equation is exact, then you have to write, what we have to write? We have to take dou m by dou y, then dou n by dou y. If both are equal, then we can say now dou m by dou y. This is the condition for the exact differential equation, necessary condition for the exact differential equation. So dou m by dou y means 0 minus 4x, okay, minus 2y square चा डेरिवेटिव 4y. That means minus 4x minus 4y. बरोबर आहे का स्टुडंट्स? dou n divide by dou y which is equals to, आता n चा dou n divide by dou x, n चा डेरिवेटिव घ्या. So 0 minus 4x minus 4y, dou m divided by dou y which is equals to dou n divided by dou x. Therefore given differential equation 1 is exact. So suppose this is a differential equation 1. आता सोल्युशन घ्या. सोल्युशन लिहित असताना काय करायचं? नाव we can use direct method. M integration of m dx. Here you note that y constant plus integration of n dx terms of n containing x means terms we can write terms of n not containing x into dy which is equals to, suppose a constant c or c dash. So we can write m dx. आता m dx ची व्हॅल्यू ठेवा रे. m dx means what? x square minus 4xy plus y square into dx plus y square आहे का काय पहा minus 2y square plus integration of, now see here the terms free from x, terms not containing x means terms free from x. n मधल्या टर्म x नसलेल्या घ्या. फक्त एकच आहे. n मधली x नसलेली टर्म एकच आहे, that is y square. So we have to take y square into dy which is equals to c dash or we can take c. काही अडचण नाही, तुम्ही असंही घेऊ शकता. So we can write this as, आता इंटिग्रेशन घ्या रे स्टुडंट्स. एक्स स्क्वेअरचं इंटिग्रेशन एक्स क्यूब बाय 3 with respect to x minus 4y. Y is considered as a constant because see this y as a constant. 4x चं इंटिग्रेशन येतं एक्स स्क्वेअर बाय 2 प्लस y कॉन्स्टंट आहे म्हणजे याचा 0 प्लस कॉन्स्टंट आहे y ना, त्याचं इंटिग्रेशन म्हणजे y कॉन्स्टंट असेल तर त्याचं इंटिग्रेशन x येतं. सॉरी, वी कॅन राईट दिस. इंटिग्रेशन सेपरेट केला तर त्याचा डेरिव्हेटिव्ह 0 येतो. इंटिग्रेशन 2y स्क्वेअर इज इट इज. सो इंटिग्रेशन ऑफ 1 विथ रिस्पेक्ट टू x इज x प्लस y स्क्वेअरचं इंटिग्रेशन y क्यूब बाय 3 विच इज इक्वल्स टू सपोज c डॅश. आता कितीनं मल्टिप्लाय करता पहा, 3 न मल्टिप्लाय करता येईल. इथं येतं 2, 3 न मल्टिप्लाय करा. सो वी गेट एक्स क्यूब मायनस 2x स्क्वेअर y मायनस 6xy स्क्वेअर बरोबर आहे का? पहा बरे इथं 6xy स्क्वेअर. हा परत काय येईल पहा आता, इथं किती येतं पहा, 2 येतं ना. 2 ला मल्टिप्लाय केल्यावर 6 होईल इथं पण. 6xy स्क्वेअर प्लस इथं येईल y क्यूबचं काय येईल रे पहा, y क्यूब यानी की 2y क्यूब इज इक्वल्स टू 3c डॅश. ओके, सो इक्वेशन येईल पहा एक्स क्यूब मायनस 6xy कॉमन काढा, x प्लस y प्लस y क्यूब which is equals to c, where 3c dash is equals to c, and this is the required solution. चला ठीक आहे, या टाईपचे खूप प्रॉब्लेम्स आहेत, ते आपण उद्याला घेऊ. नाउ वी शॅल डिस्कस सच टाइप्स ऑफ number of problems are there, so we shall discuss these types of problems tomorrow. Okay, now we shall stop here. If you have any doubt then you can ask. तुम्हाला जर कुठलाही डाऊट असेल तर तुम्ही विचारू शकता.